Okay, welcome back. And this lecture is the G30 International Program in Nagoya University. But however, last in the last lecture, for the credit, the lecture content is ended. But this is a additional knowledge for Nagoya University student. So additional student, that means before this lecture, we have discussed in the DC-DC converter. DC-DC converter, that means the chopper, boost chopper and the down chopper and some, so how to drive the power semiconductor and inductor and how to obtain the high frequency switching, the triangle waveform generator. So we have discussed some content, but from now we will discuss the inverter. Power in the power area. This is the very important topics. Interest area. The inverter is the inverter. What is this lecture is what is the inverter? We have discussed the DC-DC converter before this lecture. DC-DC converter means the battery voltage boost up to this voltage means in case of the Prius means 6. The current model is the 4th model. Obtained after the DC-DC converter side, output side is the 600 volt DC, and this voltage means DC. So the DC converter. That means the DC-DC converter, boost chopper. However, for motor drive, usually the induction motor and the PM motor, brush motor, that motor require. Later, I will discuss that why we require the AC current, but the famous type of the motor, they require AC current. Inside is DC. Outside is the AC. The voltage condition is changed. That is inverted. So we call this change to the DC side to AC side. That means that we call the inverter. Inverter means this. And the complete equivalent circuit is indicated here. Battery side, DC-DC converter, and here is the inverter. In case of for the three-phase motors driving, we call this inverter, we call the three-phase inverter. Three-phase means the one phase, two phase, three phase. Inverter is usually composed of the three phase. This is a real inverter and cooling system and a cooling fan concept. And of course, we require the gate drive circuit. However, this is a power circuit train, power conversion. Sorry. Of course, we require the capacitor and inverter. Inverter concept of the three-phase switches. Each switch power module includes the two switches here. And this we got switch ダイオードだ。ごめん。Usually the three phase, three MOS FET or IGBT is included in like this. Okay. ごめん、間違えた。Series connected for the DC side. This one called the one phase, two phase, three phase. We call usually the U phase, V phase, W phase, or A phase, B phase, C phase. In this lecture, we call the ABC. Okay, and we will zoom concentrate to the only the A phase and put up to the equivalent circuit is the here. This is the A phase inverter. In this case, we decided the one phase one. こうしようか。Most simple inverter is indicated here, and this one is the motor side, motor equivalent circuit. Motor is the concept of the windings, like the inductor. Windings mean the series connected windings and series connected resistance. Either circuit is only the inductance. However, the real circuit include the resistance, so we indicate the resistance. Here is the motor and motor overload. This single phase inverter, the switching timing is only two patterns. One pattern is the upper switch on and lower switch off. Other side is the lower switch on and upper switch off. Of course, in case of the dead time, changing time, in case of dead change time, we have the short terms. There is the off timing. That we call the dead time. However, usually we will use only the two patterns. Why there are no switching pattern? On pattern. On pattern is very dangerous because the short circuit. That means the short circuit. So the idea around the infinity current is very huge current flow through this loop. So if there are the resistance, huge current means power. Power means the heat. So broken in each power semiconductor because of owing to the heat. Okay. So let's analyze the most simple inverter. One phase using this one phase single phase inverter, we can obtain the AC current in the outside load. how to obtain the AC current. Let's analyze this inverter. ボルテージどうしようか。V out, I out. こっちをブルーラインにしようか。A, B, C. We call the each phase we call the ABC, and its switching condition indicate usually the 1 or 0. In case of that A phase, in case of the 1 means the upper switch is turn on. Upper switch is turn on. That means the lower switch is turn off. In case of 0, lower switch is off. This means upper switch is off. Only 2 switching mode in case of the single phase inverter. So the phase A, 0. Please indicate, please illustrate the each V out and I out. In case of the 1, 0, 1, 0, 1, 0. That means that phase is switching condition. Okay. Please write this waveform using your notebook. こっちですね。In the lecture of this seminar lectures, transient phenomena, the sixth, seventh, I forget the number, but we have discussed the transient phenomena. This inverter uses the transient phenomena. In case of the A1, the equivalence, please write the equivalence circuit. Because in case of the A equals 0, red line. Please write the current loop. For the circuit analysis, the current loop is very important. Loop is important. I have already mentioned the other lecture. Okay? Remember? In case of the upper switch on and lower switch off, current flow through like this, cannot like this, only to the load. So plus to switch on and flow through load, and we cannot do through here. So current must flow through the loop. So loop, okay. This is a equals 0 current loop. So that means the equivalent circuit is the And blue line equals 0. Current flow through like this, because of the inductance. Oh, first current flows through here. So in case of the out of the load, 100 voltage across to the load. So the load is mean 100. And current flows through transient increase the current value. So the current value is increased. But the transient phenomenon, in case of the increase, the value increase, the transient curve is here. Down is here. Okay? Remember? So current flows through like this. Okay. And current flows through this. In case of the switch off, 0, a change to the 0, current is flowing because of the inductance influence. So the current flows through, however, turn off. So we cannot flow through here. So we can flow through only this loop and this loop and here, this. Flows through this loop. So in case of the equivalent circuit is this mean here.こう来てんな。こんな感じ。Across to the voltage, it's minus 100. Okay. And decrease the current. Decrease mean the value is here, curve is here. So the decrease. And repeat alternately. 100 minus 1, 100 minus 1. Okay. So current is increase, decrease, increase, decrease, decrease. This is a very simple inverter. Output side, as we can, using the battery, DC battery, we can obtain the alternating current, plus side, minus side, plus side, minus side, alternating current. This current means AC. We can obtain the DC from the DC battery. We can obtain the AC current. That means we call this system, we call the inverter. That is the essence of the inverter, okay? However, the single-phase inverter is increased in the power system. We call the This is a single-phase inverter. However, we can already obtain the single-phase inverter, a single-phase AC current. However, usually we use this type of the single-phase AC current for obtaining the AC single-phase AC current. We require this type of the equivalent current, equivalent circuit. This is a conventional, famous, traditional single-phase inverter. Why require the A phase and B phase? Two phases is required. Why? Cost is higher. Control is complex. Gate drivers required in each switching system. Why required two phase? In the next lecture, we will discuss that. I think that it's okay. Already we can obtain the AC current. However, we must prepare the two phase for the obtaining only single phase current, a single AC current. In the next lecture, we will discuss. And two lectures later, we will discuss why the AC motor required AC current for motor driving. I will discuss later. Okay. In the first step of inverters lecture that's all. Thank you very much.